So very good morning to all of you guys. I hope you all are safe in your home. Okay. So guys, in the last session we have seen whenever there is a charge moving parallel to the magnetic field, then there will not be any effect in the velocity of the charge. But as the charge is moving perpendicular to the magnetic field, then it will create a circle. I mean, it will rotate in a circular path. It will take a path of circular motion, right? This we have seen in the last class. And we have seen also if it is moving in a oblique path, means if the magnetic field is this in this path and the velocity of the charge is in this path, means it is making some angle with the magnetic field. Let's say this is the magnetic field, this is the velocity. So if it is moving with some velocity, so it will take a helical path around it, right? There will be two components of the velocity. One component will be in the x direction, one component will be in the y direction, right? This y direction component will be perpendicular to the magnetic field, and this horizontal component will be parallel to the magnetic field, right? So what happens is actually, this velocity, horizontal velocity, is responsible to drag it into x direction, and this perpendicular velocity is responsible for a circular motion. So combiningly we will get one helical motion here. So let's see some aspect of the helical motion. So here helical motion, how we can get helical motion? If the B magnetic field is in this direction and the velocity is in this direction like this, so if it is making an angle theta with the magnetic field, so obviously there will be two components of the velocity, that is V sine theta and it is V cos theta, right? This V perpendicular is V sine theta and V parallel is V cos theta, right? And this is responsible for circular motion. And this is for motion in x direction. So if you combine these two motion, you will get the helical motion, right? Okay. Now, so how it will be? Let's say it is like this. This is x direction, this is y direction, this is z direction, this is x direction. So it will move like this. Like this. So the motion will be like this, right? So it will move like this. How? It will be rotating like this, right? So the radius, can you tell me what will be the radius, guys, here? What will be the radius of the helical path? The radius will be, that will be same. Why so? Because the velocity, because there is some velocity in the perpendicular direction. Okay, so instead of this we will write here P perpendicular. And what is that P perpendicular? So R here will be mv sine theta by qb, right? So one term is called pitch. What is the pitch? It is the distance between two circles, right? One circle is this, one circle is this. See, like it is moving like this. Okay. Here, if you can see, it is completing two circles like this. Means the distance between two circles. Between two circles. It is called pitch. See guys, the pitch means this is the forward motion. Pitch is the forward motion, right? Like this, it is a forward motion. So how much time it will take to cover one circle? Tell me guys, how much time it will take to cover one circle? That time period will be, if you remember, 2 pi v perpendicular by, 2 pi r by v perpendicular, or ultimately it will be 2 pi m by qv. Yes or no guys? Tell me. So can you tell me what will be that pitch? Means if it is completing one circle like this, it is moving in forward direction also. See, like this. See, it is started from here. So it is completing like one circle here. So how much it is moved? See, let's say it is started from here like this. So see here like this. It is started like this and reached up to here. Means here. So this is the pitch. See, it started like this. Like this. So how much distance it is covered? How much distance it covered? This much. This is called one pitch. See, this is the one pitch, right? If two, see, it is moving like this. Like this. So it is covering one circle like this. Sorry, one circle will be like this. Like this, one circle will be there here. One second. So it moved this much. See, it is moving like this. Okay, so it is covering one pitch. So when it is covering one pitch, in how much time it is covering one pitch? I think this time, right? How much it is moved from here to here? Tell me how much it is moved from here to here? From here to here. This is pitch, right? And what is the time taken here? Time taken is this one. So what is the velocity in this direction? That is v parallel, v cos theta. So pitch is equal to vx into time. Vx into time period. What is vx guys? Vx is v cos theta. And what is time period? 2 pi m by qb. So this will be the pitch. I hope this is clear for you guys. Tell me, in how much, in one pitch, how much it will rotate? I think it will rotate one circle, right? See, it will start from here like this and it will go up to this pitch. See, like this. So how much distance it is covered? This much only. So this is called the one pitch, right? One pitch will be this much. Just take this down fast. If a charge is entered in a magnetic field which is of d distance, from here, okay, it is inward, like magnetic field is this much only. Okay, now we send a charge with some velocity v, that is a positive charge having a mass m with some velocity v. Tell me, will it be able to create the full circle? I think it will not be able to create the full circle. Why so? Because to create the full circle, the electric field, the magnetic field should be this much, so that it will create if it enters here, so it will create the circle like this. Yes or no? If it is too much, like here also, if the field is here also, so it can create the circle like this. But if you see carefully, the field is this much only. Will it be able to create the circle here? I think it will not be able to create the circle. So how it will go out of the field? It will go out of the field like this. It will making some angle. It will be making some angle theta with the horizontal, and it will go out of the field. But we have to find at what theta angle it will go out. Means we have to find the deflection angle. We have to find the deflection angle, means this theta. So let's do one thing. Let's make a imaginary magnetic field. Let's make imaginary magnetic field. Okay, this is the imaginary magnetic field, and this is the distance d. Right? This is the distance d. Right? See guys, if it enters like this, let's make here also. Yes. So this is the field. Field is inside the plane, right? I am just making the symbol. It means that it is uniform field. Okay, it is uniform field. So the charge is entering here like this. So what will happen? It will create a circle like this. Okay. Let's say this is the d distance. This is d. So it will come out like this. So obviously center will be here. Okay. If half is there, we have seen that if half magnetic field is there, it will go like this. It will come out like this. We know already. If it is like this, the field is like this. It will go like this and it will come out with the same angle. Yes or no? The center was here. For this center, where will be the center? I think center will be here. If it is going straight like this, okay, so angle will be, so the center will be here. So this is the same case. It is going like this. Velocity is going like this and coming back like this. So this is d distance. Okay, so let's make it here. So this is imaginary field. Okay, so it is going like this. It's coming out, making a circle. It is coming out at the same angle. What is the angle here, guys? I think theta here is 0, right? So theta here also should be 0 only. Yes or no, guys? Tell me. So this is the d distance. So we have to find out the deflection if the thickness of the magnetic field is d only. So can I say this is the center here? Tell me, guys. Or can I say, so we have to find this angle. This is what? This is, let's say it is alpha. Let's say it is alpha angle. Okay. So we have to find the alpha angle, means at what angle it will go out. Right? So now, this is the radius. Yes or no? Tell me. And this is also the radius. Yes or no, guys? Tell me. Tell me, guys. Okay. So now, if you join this like this, so you can have something like this. Okay. This is D, this is D, this is R, and this is alpha. You see, if you make, see, at this angle it will go out from here. If you clearly observe this angle alpha, so this angle also will be alpha. How it is, guys? See, if this is 90, this is 90 minus alpha. Okay, so obviously this will be 90. Why? Because this is a tangent to the circle. Tangent to the circle means this angle is 90 degrees. So this angle is 90 degree means this angle is how much, guys? This will be this one. This one will be 90 degrees, right? This one will be 90 degrees. So this angle will be alpha. Okay. This angle is also 90 degrees. So this angle will be 90 minus alpha. 90 minus alpha. So this will become alpha. Did you understand this or not? Tell me. So at what angle it is leading? The angle which is made on the center with this point and this point. See, let's say this is point AB. What is the AB point? That is D. See, so the angle made by this AB and the radius R on the center, that same angle will be the angle of reflection. Did you understand this point or not? Tell me. Shall I explain one more time? Okay, let me explain you one more time. Let me make the figure here. Up to here it is clear how I made this figure circle like this. Is it clear? Is it clear? See, when we send a charge at an angle, let's say it's an angle theta, so obviously it will come out with a theta angle. Here we are sending the charge angle 0, so obviously it will be come out at 0 degrees. So actually it is making a half circle inside the field. So let's say this is the D. We are making the imaginary magnetic field, and we are assuming that it is creating the full circle inside, and let's say it is a D distance. So let me make you one more figure for you guys. So how we have that one? So we have like this. Okay, this is the D, right? And at this angle it is leaving, right? This angle is alpha. At this angle is leaving, right? So see guys. Now I'm not saying it is angle alpha. Let's say this angle is alpha. Okay. So let me make a perpendicular like this. Okay, guys. See, guys. Now this angle is alpha. This is 90 degrees, so it will be 90 minus alpha. Yes or no? If this is 90 minus alpha, this is total 90, so it will be alpha angle. This is 90 degrees, okay? This is alpha, so it is 90 minus alpha. So if it is 90 degrees, this one is 90 degrees, so this angle will become alpha. I hope this point is clear for you guys. Tell me. Okay. So now can I say from this side, sine alpha is equal to, tell me what will be the sine alpha, guys? Can I say this one? Tell me. Is that point clear? Is the point clear, guys? So you can take this down and you can write the deflection of a charged particle from a thickness of magnetic field. Let's say it cannot create the full circle, right? Why it cannot create the full circle, guys? Why it cannot create the full circle? Tell me. See, magnetic field is this much only. To create the magnetic field, to create the full circle, it requires this much field, right? To create the full circle. But the field is this much only. Means field is at this space only. So we make an imaginary field like this, okay? And we'll assume that it is making a full circle. It is coming inside at theta equal to 0 angle and coming out also at theta equal to 0 angle. So let's say this length is t. So we will make the geometry of this and we'll get the alpha angle. Alpha angle is sine d by r. I think this point is clear for you guys now. So I'll give you one question. Just try this. Okay. Question is, find theta if d is mv by qb. mv by qb. So what is mv by qb? Do you remember guys what is mv by qb? Huh? I think it is the radius, right? R is equal to mv by qb. Means we have a field. Okay, let's suppose we have seen a particle, charged particle, some velocity having a mass m and charge plus q. So it will try to make the circle like this and it will come out. I'm doing one question I will give you to solve. So what is the thickness guys? I'm sure thickness will be this much. This is d, because this is r and r is what? mv by qb. So can you tell me what is the deflection guys? Can you tell me the deflection? What is the deflection? Deflection is here, right? Okay, from the horizontal. So I think theta here is, it is 180 degrees. 180. Why? See, it goes here, but it come back like this. See, it is coming back like this. See. So what is the angle? Here, 180 degrees. Okay. So it is coming out. Actually, it's going like this, but coming like this. So angle this one is 180 degrees. Okay. Now we try. If d is mv by 2 qb, find theta. This question is for you guys. Find theta. This question is for you guys. Just try, I will give you 2 minutes. So let me explain you this. Okay. So the thickness is d, right? And that is equal to r. Sorry, this one. So it will go like this. Plus charge, mass is m. So it will try to make the circle like this. Okay. But here the field is finished. Okay. If you make write the formula, sin alpha is equal to d by r. So it is d is how much? R by r. So it is 1. So alpha is equal to 90 degrees. So it will go like this. So alpha is equal to 90 degrees. Let's see here for this one. Okay. So now the d. Yes, huh? Okay, just one minute. So here the d is r by 2. D is r by 2. So it wants to create the circle, but it will not be able to create the circle, right? Okay, let's say this is the r, this is d, so this will be the alpha, and this angle is also be alpha. Okay, so alpha will be how much guys? Sin alpha is equal to d by r. So d is r by 2 into r, r will be cancelled. So sin alpha is equal to 1 by 2. So alpha is equal to sin inverse 1 by 2, that is alpha is equal to 30 degrees. So homework for you guys, just try this. If d value is 2 into mv by qb, find alpha. Okay, this you have to try. Okay guys. Okay, so we are going to stop this session here only. So bye guys, take care.